Thanks a lot, Mike. Yeah, it is nice to see a lot of familiar faces here. It's great to be around Mass TLC. I think I remember the CTO VPE group that Mike was referencing, talking about the high interest credit card paper and other things a few years ago. So I am a chapter lead for machine learning at Spotify, our office in Davis Square. There are a number of the folks that I have the privilege of serving as manager who are here. You can probably recognize us by our hoodies or other Spotify swag. So I want to talk today about how to train your product owner. So this is an image from the movie, How to Train Your Dragon. I'm going to get into what the analogy means, but the reason that I know this movie is because I have kids like the one that's on my shoulder in this picture, so it's something that they're really into right now. So in this analogy, Hiccup, or the boy on the left, that's your product owner. And the dragon, that's not you. That's your product. You, my dear applied machine learning developer friends, you are dragon-making demigods. You make these wonderful dragons. Now, they're not magic, as we know. They're a lot of math. They're more than math, like we said before. But through the course of this talk, I want to help you train your product owner. Now, how many of you have some person that you interact with, say, daily or weekly, who would consider themselves a product person professionally? Do you interact with some product person? All right. And now, hopefully they're not here for this question. How many of you would like them to know more about machine learning and product than they do? Okay, that's pretty good. So good. Hopefully I can help you out in some ways. Now, at Spotify, of course, our product is not dragons, it's music. The reason I work at Spotify is that I believe music improves lives, both of those who are listening to it and also the creators who make it. This is an example piece of music, or piece of our product. How many of you have used Spotify or ever listened to Spotify? Actually, I happen to know you've all listened to Spotify because our walk-ins that we're using here, Google walk-in playlist, I got to take a look at a second ago on Spotify. So that's your source of music today as we're walking in. How about Discover Weekly? Anybody listen to Discover Weekly? Cool. So Discover Weekly shows up every Monday, and it's a bunch of tracks that you've never heard before that we think you're going to like. So I'm going to reference back to Discover Weekly and some examples here as we go along to try and ground some things. Now, of course, I'm talking about product owners, and it may be that not all of us absolutely know what product owners do. It's a notion that's common in Agile, but maybe in different kinds of organizations you may not have them. Very simply, product owners lead the team in establishing a vision or set of hypotheses for what the product should become, and also prioritizing the work to get there. So those dear, wonderful product colleagues of ours, how do we help them do this in the context of products that have machine learning? So not all of us have products that are music, or they're all different shapes. So I'm just going to use a box that looks like this as a representation of your product. And then as we're going through different things that you might want to teach your product owner, we're going to call him Hiccup, because that's the name of the character in the movie. I'm going to try to illustrate it by highlighting different things about this little black cube here. So your product, as we were saying, it has some machine learning element. That's that bit of orange inside it. And I think like the high level message here is, as you're talking to your product owners about how to help give leadership to this product and your team, I think there are two ways to help talk to them. One is to encourage them to take it outside in. Like if you start by explaining what an LSTM or a GAN or a DeepNet is, you're wrong. And if your product owner gets really engaged in that, they're wrong. What you want to do, and yeah, I mean, like if they're super nerdy, that's cool. Like do it on your off hours, but they need to go outside in. They need to know the shape of the outputs of the product and also the inputs. And then also they need to worry about how to get a product that has machine learning in it from where it is now to where you want it to be then, your future product. So I'm going to break down the ways that I think you should talk to your product owner Hiccup about in these two different ways. More particularly, under outside in, we're going to talk about 5 different things. You can see them there at the bottom. We'll walk through them. And then in terms of going from now to then, 2 additional things that have to do with as their product's changing. So let's go outside in first. So let's talk particularly about picking a problem. Now, at Spotify, there are 2 especially areas of this sort of product development lifecycle, the way the product owners think about it. We call it sometimes tweak it and think it. And along with ship it and build it, they're a big part of our kind of the way we think about product development. And there are ways in those parts of the product development process to bring machine learning to bear. So the first thing is, and this is the way I recommend if there's an existing product and somebody's saying, how should we get machine learning in here? It's so buzzy. Shouldn't we do that? So I would say to them, don't just follow the buzz, but instead follow a process like this. What is the business goal of your product? What are the high level, pictures of George Washington business metrics that are going to lead to dollars or whatever else the mission of your organization is? And then what fuzzy decisions does the product make that impact that goal? And I mean fuzzy in the sense of you can't write down a recipe that's always going to get it right. And those are the places where machine learning can help. So that's one way to help your product owner sort of focus in. And then you want to ask on top of that, and we'll talk about this more, what metrics do you have for those decisions, what data you have, that sort of thing. But maybe you've got a complete blank slate. You're a startup, you're saying, what kind of product, could we build just to help the world? This is more the think it stage, so this is much bigger. So here, there are a few different ways to think about it. One is, I think there are kind of 3 categories of use cases or products that ML can really help with now. So one is if it requires something that a person can do in a second. So computer vision, language processing, speech, and credit to Andrew Ng for articulating this the first time. Also, if it's something that is done over and over, so you have a history that you can learn to predict from. That's another one that Andrew Ng said. I think it was at Stanford, giving a talk on that. And then there's one from yours truly, maybe unsurprisingly, at Spotify. If there's some personalization need, it's some similar need that still is met in different ways, but it's something shared, that's something that machine learning is good at. So maybe thinking about, is there something in the, for the problem space we want to be in, is there something having to do with perception, prediction, or personalization? Now, before moving on to design, or as moving on to design, I want to highlight how important product owners and designers are in the success of a product. So here you can see this is basically what the discovery feature looked like in Spotify before Discover Weekly. This is still there. But you can see down on the bottom shelf there, it has, because I listen to Blind Pilot and Gregory Alan Issakoff, it's going to recommend to me whatever, Iron and Wine, or so the same model, or a very similar model that's behind Discover Weekly, was behind this product, and it had hugely different success when we put it in Discover Weekly. So the shape of the product, the way it fits into the user's life, the accessibility of it makes a really big deal. So just because you have the world's most amazing model, if your product and design folks are phoning it in, you're in trouble. And this is, again, what Discover Weekly looks like now. So let's talk about design. So got a little color wheel there because designers think about that stuff, I guess. 4 questions I think are important when you're designing a product with ML. So the first one is the role of why, the role of interpretability, expressibility. So in that example, I showed that it was illustrating, because I had listened to Blind Pilot, it was going to give me Iron and Wine. So as you know, usually with different machine learning models, there are trade-offs. And one trade-off is this interpretability versus quality, or being right, trading off why versus right. So that's something to think about with your designer, and encourage the product owner to think about in their own mind. Is interpretability, like how important is that versus the core quality of the product? And at what level do you need both of them to not be embarrassing? Also, the granularity of why. So the product owner and her or his design colleague should be thinking about, do you want it expressed as, because you listened to this artist? What if it had said a particular song, like Amsterdam by Gregory Alan Issakoff? Because I listened to that, it was going to, would that be cool, or would that be kind of weird and creepy? Or if it had just said, because you listened to folk, we're going to give you this. So that gets to this creepy and personal distinction. So the very first step, and this is something I'll come back to, like the way teams should communicate in machine learning products is by like writing down data and showing data to each other. Like rather than, it's almost like data is the new, API. It's that this is the kind of thing that, I think that, the designer says, I would like this to be interpretable because with these recommendations, I think it should say things like this, to be very concrete, and that's a way of communicating. So product owners should be encouraging the designers they're working with to do that. Second question, coping with errors. So we all know that despite all our best efforts, there's going to be some inherent error rate in our machine learning products. So there are different questions of quality for the designer. What quality is needed to maintain the trust of the user, to delight the user? Is that a different thing? What mental model, what relationship is a designer trying to build with the user? And we know that sometimes you're not going to necessarily get the absolute right answer as the top answer. Do you want to give the user means of coping with these errors by producing multiple results, like a search result page from Google's most popular product, or at least the most popular thing we use? I guess AdWords is their most popular product in a sense. Anyway, do you want to provide fallback behavior? So a situation where, let's say in your Discover Weekly, you could correct that and you could remove tracks that you didn't like and go back and listen to it. Do you want to provide some explicit feedback mechanisms? Coping with variety. So, like we were talking about before, thinking about the variety of kinds of users and data that our systems can analyze and watching out for bias in that. Sometimes designers can be concerned about or need to be concerned about getting realistic output from a variety of users. Maybe you have synthetic users, maybe you use personas. So there's a fun story here, as I understand it. The folks at Facebook some years ago were thinking about designing the news feed, and the designers there designed it in a way that was really put a strong focus on photos. And when they deployed it, they realized that that was because the users that they were looking at and themselves had a high proportion of photos in their news feeds. But when they looked at it globally, it was much less. And so they didn't have this representative set of users. So even though a designer can say, here are my UI elements and here's how they're all going to fit together, if the data that's going to come through the news feed of the average user doesn't jibe with those design elements, then it's a net loss. Finally, there are new user behaviors that machine learning can engender. So especially if the machine learning system acts as sort of an agent and it initiates some kind of interaction with the user, it can be anthropomorphized. So the users might say, I don't just want to tell you, dear Alexa, or whatever, Google Home or Spotify for that matter, what I want to listen to, but I also want to, complain to your customer service department or something. What are the boundaries of the kinds of things that you can do if this thing, represents that entire product entity? Also, similarly, users might express more of themselves. They might have these sort of boundary testing behaviors. And of course, you can get into these user bubbles where the content that you show them is the content that they consume, is the content that you show them, and then, I don't know, you've heard a lot about that in the last year and a half, I suppose. So metrics. So, okay, you've interacted with the designer, you've helped your product owner interact with the designer. The product owner needs to understand that metrics for machine learning-based products are not just the high-level business metrics or, how fast does it go, or sort of the traditional quantitative metrics. In addition to that, I think there are sort of 4 properties of metrics that it's useful for your product owner to realize. So they'll be familiar with alignment to business value. That's something that they do regardless if there's ML there. Or think about the effort to measure. Like if it's a metric that is very expensive to measure, you want to take that into account. But especially, to what extent is this metric around machine learning useful for the team's decision-making process about what to do next? And also, how useful is it to train your model and actually make your model better? So I think there's sort of a 2x2 matrix of metrics for machine learning products that we can think of, where one dimension is it online, meaning if you have a product that has a service component or an online component that you can put things in front of users and test 2 versions, or is it offline? And is the metric itself heuristic-based, meaning you're counting things in a very straightforward, way, like precision or recall or F measure or normalized discounted cumulative gain or whatever, or is it modeled? Have you built a model from a set of signals that is itself a metric? It's giving you some number of pseudo satisfaction of users or something, and those 2 dimensions, I think, correspond to 2 different kinds of trade-offs. One is for online and offline. Online tends to be more aligned with business value because you can more directly measure the engagement of your users. What kind of actions are they doing? Whereas offline, generally less effort to measure. You don't have to deploy something new. You don't have to wait for X% of users to go through. And you can turn it over as fast as your CPU can take you. Heuristic versus modeled. Heuristics sometimes are more useful for teams' decisions because they're more interpretable. So if you say, all right, what does this precision mean? Like, what does precision of 70 mean? It means of the stuff we returned, 70% of it was right. Okay, and for this error category, what? Okay, that's lower precision. Okay, I understand what that means. Whereas, you know, our modeled metric told us that it was 0.83. It's great to whack the machine learning model on the head, but maybe it's harder for you to decide what to do about that. So going back, just to give you an overview again of those matrix. Now there's one other kind of what I'll call a pseudo metric. So this is sort of a subjective metric. This is when someone says, well, have somebody look at the before and after and tell us if it's better. And that's, it's dangerous, but it's cheap and it can be useful. You just have to watch out. Obviously, it doesn't scale in the long term, but it's real quick to do. Just we got to figure this out before, our sprint planning meeting tomorrow or something. And, Sue thought it was better or something. Okay, let's move on to data. So a few questions here. What data do you need? And in this case, so I've started going the outside in. I've started going from the user problem to the metrics and how are you going to measure how well you're doing that. Now I'm like going to the other end of the product and saying, what data do you need down below to feed this thing? What kinds of ways should the product owner be thinking about data? How do you tell them about data? So I think there are a few different questions. What data do you need? What data does the product need? Where can you get it? The product owner has a lot of domain knowledge and they can help you figure out where to get that data. And then what biases does it carry? And Eric and Dee did a good job talking about an example earlier today, so I'm not going to dive too much into that, but it's a very important question. So in terms of the data you need, I kind of think of it in 3 buckets. So there's sort of the raw input data that's exactly like the kind of data that you're going to see in production. So you need that to train your model, to evaluate your model. Then it's nice sometimes to have metadata that's associated with that. So this might be, say, in the example of Discover Weekly. So the raw data might be, here's just all the tracks in the Spotify catalog. And metadata might be, and here's a genre tag for each one of them, or here's the label that put it out or whatever. Sometimes this can also be called reference data, where it's some reference to a dictionary or some other taxonomy. And then the third is that not only does it have metadata that's just additional information, it might have metadata that allows you to do measurement. It might say this is the right answer or it's not the right answer. And of course, that could be at varying level of quality. Sometimes you'll call it a gold standard, or people riff on that by calling it a bronze standard, or and then you can do tuning and training and hyperparameter tuning, that sort of thing on top of it, cross-validation, those things. Now there's another kind of data you need, and I'm going to pull back out for a second here outside the product. This is just making the point again that often you need to ask your product owner to specify with data. So a catchphrase here is that data is the new wireframe. I think it's great to say, have the product owner write down, like, here's, for these 50 inputs, here are the exact outputs that I want. Like, type it into a file, and then I'm going to measure my metric on that. And if it turns out that it's 0.83, then the product owner gets to say, yeah, okay, that seems like about 0.83 quality. Going back inside, so whether you're using the data from the product owner or from other sources, some of those other sources are logs. So again, if you have an online product, a service product, you can look at how folks are using it, depending on what you're allowed to log. Proxies and other third parties. So an example of this might be, so let's say in structuring Discover Weekly, we have some space that we've put all music into, and we can measure distances between those things. Well, there may be other spaces that third parties have developed, like in Wikipedia, what is the Wikipedia distance between these 2 artists or these 2 genres? And we can do comparisons of our space to another space. So it doesn't necessarily have to be just look inside your product and, get in a time machine and slice off the most recent stuff and try to predict it. For some kinds of tasks, like perception tasks, especially annotation, write down, is this a smile in this picture, something like that. Drift in the data set over time. As you get data, sometimes it'll drift out from under you, and if you're training from one data set and in production you're actually seeing something else, that can be a challenge. And again, especially when it comes to feature or signal engineering, take advantage of the PO's domain knowledge and encourage them, help them understand that when they identify some signal that might be correlated with the way you want your product to be better. So I'll just briefly mention biases here because we had a good talk earlier on it. Just To what extent is your data skewed? Do you have a whole lot of folk listeners on your platform, in which case maybe Discover Weekly is going to be better for folk? Is it tainted in some way that it itself represents like even more kind of pejorative biases? Or is it likely to stereotype? If you have something like gender as a really key information bearing data point, well, that can be correlated. The statistics are the statistics, but you need to be careful that if that alone is the source of your prediction, it may be that it leads you to stereotype in cases that are really not helpful. Okay, now I want to say, what should you say to product owners as you're training them about models if you're not going to say letters like LSTM or SVM if you're feeling old school or whatever? So first principle is to teach tasks rather than techniques. So I think it's not valuable for product owners to know, to like figure out what gradient descent is or something like that. But I think it is valuable for them to understand the distinction, say, between classification and clustering, or between that and regression. And if you need to tell them about embeddings or vectors, that can be useful too. And also to talk about trade-offs rather than tools. So trade-offs in selecting a model. So I think Angela talked a little bit about this earlier, the value of simplicity and interpretability and being able to reason about the model. Or can you get a result with confidence so you can choose those operating points along your AUC curve? Accuracy itself and an important sort of core thing, but then adaptability to new domains, or speed, space, scale, sort of the traditional software properties. And finally, just to emphasize it again, to err towards simplicity. So I always say machine learning should be your approach of last resort. The problem is it's a really cool resort. So you have to have that restraint. So rules before baseline models. These might be models developed other places that you could just apply with straight out of the box, just see how well it does. Baseline models before adapted models, something you take and then adapt to your product, and then adapted models before end-to-end models, where you're trying to train just in your own view of the world. Even though end-to-end is most likely to maximize accuracy, is the effort invested in that and the maintenance burden you're going to take on, is that really worth it? Okay, so we talked about training your PO going from outside in. Now I want to talk about how to get from the product you have now and how to help that product owner lead you to the place that you all want to be. So the first thing is talking about prioritization. So for this, I'm going to turn this machine learning product there into your backlog. So, of course, your backlog is your future product. It's the source of your future product. And talk about ways that you can help them figure out how to groom and populate a backlog for a machine learning product. So the first is exploration. So often if you're doing, say, a sprint planning or something, there's this question of what do we put in here for you machine learning people? What's the shape of your thing? What's a definition of done? So I think there are a few sort of patterns here. One is this sort of exploration pattern. This is a screenshot of a Trello card. So exploration, right? And this is also in the data wrangling, data cleaning category to some extent that we talked about earlier. So being able to demonstrate important relationships in the data, to describe the quality of the data. So this is one kind of task. Another one, experiments, I think is really valuable. So if you've done sort of agile product development, the product owner is interested in saying, I want guaranteed business value. And almost always that means metrics are going to move up. And so they would come naively and say, I want something here that says you're going to raise blah metric by 2%. And you machine learning developers say, I have no idea if I can do that in the next 2 weeks or whatever. And they say, but I need some value. And so you say back to them, okay, I promise that I'll spend 5 days working on this problem. It'll be a time box. And they say, you can't do that. That's just, I have no idea what I'm going to get out of that. Experiments, I think, are the solution to make everyone equally offended. And that is, the product owner knows either that they're going to actually get some improvement, they don't know how much, or they're going to get, and notice the way it's written here, or they're going to get some error analysis. They're going to get some idea of what happened, why it is. So even if they don't get immediate business value. They're going to get learnings, which can turn into future business value. And then you, as a machine learning engineer, can say, okay, I can carry out this experiment or this line of experiments. I can predict that can get done in the time allowed. So I think that's an important balance point. Another thing that's important to clarify with your product owners is the distinction between a bug and an error. So a bug is when the person writing the code wrote something that they didn't mean to, or they would come back later and say, oh, that's not right. Like an off by one error in an array index or something like that. Whereas an error is something that's an intrinsic quality of the, fuzzy system. We know whatever model we build that it's going to make some mistakes. So those errors are not a thing to just fill up your issue tracker with. You'll go crazy. Instead, gather them somewhere else, look for systematic patterns in them, and then turn that into, oh, here's an experiment we could do to go after this category of error. Similarly, and there's a whole lot more that could be said under this heading, the value of looking at learning curves and the progression of metrics with more epochs or more training data and trying to decide, do you need more data? Do you need to let it train longer? Do you need maybe some different model, some regularization? That can be valuable for the more sort of advanced product owners to try and grapple with that and look at the metrics and help you look for trends and then justify, oh, look at this. Yeah, it really is a good idea for us to say, I don't know, spend more money on our computers or something to do more training epochs. I think when it comes to prioritizing, it's really useful to think about where in sort of the product life cycle you are. Are you initially exploring? You should do just by hand examples. Those are the main characteristics, or maybe some rules to just sort of get a feel for, is there even a there? Could someone's life be made better by this thing we're thinking about doing? Then as you're earlier on, say what I'll call pre-MVP, you focusing on having something that's measurable, inspectable, understandable. It's not so important that you know exactly, that it hits a particular quality. The quality comes in the MVP stage, then you make it simple and fast, then you expand it to new domains. So those are sort of the characteristics. And often talk about something like OKRs or setting longer term, say quarterly goals. So this is something I think we're all still figuring out, and apparently I'm figuring out how to put tables on slides, but at different stages of product development, what kinds of things could you be measuring? So if it's super early, you could say, well, we're going to do this amount of analysis, or we're going to analyze this amount of data. Pre-MVP, you might be saying, we have metrics, we've done a certain amount of experiments. As you're getting close to MVP, we're actually able to move core metrics. Maybe you've moved them by this amount, or you hope to move them by this amount. Again, sort of amount of experiments. So you're getting to V1, you want to be able to move all metrics, so not just accuracy, but speed or other things, or just have awareness of them. And then post V1 is that same thing on new data. Okay. So last little bucket across the bottom about organizing. So how can you help your product owner figure out how to organize a machine learning team or a team that's doing machine learning? So I think the key here is to align it to the place in the product lifecycle that you are, and also just as an organization, your maturity. So when you're really early in the stage of the product or your organization, there's not much machine learning happening, it can make sense to have a centralized machine learning team, because you don't know which teams are going to need how much machine learning on what scale. You need your machine learning folks not to feel like islands. You need to be able to collaborate and sort of centralize your skill together. Obviously, it's really important that you align with the needs of those product teams. As you get a little more mature, I think it makes sense to go to a cross-functional team. So have machine learning engineers on the different teams. They have to be strong enough that they can represent their discipline on that team and have connections. So this is where chapters or guilds at Spotify, for instance, come in to connect those folks to each other. Once you've gotten to MVP and you're really like doubling down to really push metrics, I think still cross-functional teams make sense, but having what you might call a separate work stream where it's not that everybody's always working on everything, because that can lead to dilution of attention, but you are still planning together. you're more aligned than if you were completely separate teams. And then finally, post V1, and not that many products actually necessarily need to get here. It may be that you've got something perfectly wonderful, but if you decide that squeezing out that next 2% is really worth the investment, having what I'd call a sibling team. So this is one, maybe it's separate planning, maybe it's joint quarterly goals or something like that. But one that has a more heavy machine learning component, but also has a product owner who's really, who you have trained, like wonderful Hiccup, your product owner, who can really give that direction. Okay, last topic, roles. So I feel like building machine learning products is like building, say, a wooden chair, say a lovely Adirondack chair or something like that. There are a few different roles. The folks that, maybe are mostly in this room, I might call applied machine learning engineers. You're like carpenters. You take data in the form of raw wood, or raw wood in the form of data, whatever. All analogies are limited, even this one. And you turn it into something that's useful with the help of other kinds of crafts people, product owners, designers, those sorts of things. Then there are tool engineers. So these are like the blacksmiths. These are the people that are building the hammers that you're using. And then there are more core researchers. So these are folks who are at the rock face of nature and figuring out, new techniques, new ways to push things. I think in general, you need more of the higher categories and less of the lower categories in your organization. And as you're thinking about staffing up these teams, be careful about getting, just the amazing hotshot researcher who's going to want to be at the cold face of nature when all you want is an Adirondack chair, gosh darn it. So be careful about that. So wrapping up, I suggest when you're talking to your product owners, take them outside in. Don't try and teach them about fancy techniques. Take them outside in, talk about how to identify the problem, how to design the product, how to pick metrics, where you can get data, what kind of data you need, and the trade-offs and the tasks that models can do. And then talk to them about how to take your product from here to there, how to integrate machine learning into the things they're already doing, prioritizing and organizing. So with that, I'll say thank you. Open it up for questions. I have some suggested questions if you don't have any yourself, but I would much rather have yours in mind. Thanks a lot.
I'll kick this off with a question. As sort of a machine learning expert, how do you define just because you can, should you? Sort of that creepy verse, cool factor, or like sales rep says, hey, I really want this, and you're like, that's sort of going over the line. I can do it, but I don't want to.
Yeah, it's a great question and obviously huge, and I think it's incumbent on all of us to, have a sense of ethics or values as we're building these things, because, we're wielding, we are the dragon creators of the world, right? Or at least there are other people doing all kinds of amazing things too. I know there are people curing cancer, and that's like, I'm just putting music in their ears. But yeah, I think to me, it's really about looking at the company that you're working at and what are their values. So at Spotify, our values are collaboration, passion, innovation, playfulness, and sincerity. And especially that last one, sincerity, is really important to us as we're thinking about, what kinds of things we can do. And we have like plenty of conversation about like what is, the right thing to do in this situation, and is this thing, as we're balancing needs, say, of artists and their audiences, and how do we do that? And I'd say, the places that you work, if the values are just sort of written down on a napkin or stuck on some like, sign in the bathroom or something, and no one's really living them, then I don't know. I know I'm getting all philosophical here. I guess we did a little earlier too, but I think that's really where it comes to. So put yourself in a place where you agree with the values, and then trust that when you make a decision in line with those values, that you're going to be supported.
Questions? Did everyone fall asleep before the last session? Oh, here.
Hi. So question, you talked a little bit about keeping it simple, and to follow up on that question of when machine learning is just the buzzword and the thing that we should do versus when we should actually do it, what steps do you take to avoid machine learning in a situation where there maybe is a simpler solution.
Yeah, and I guess that's the other part of this. I was sort of doing that just because I can, should I, and there's should in the sense of like ought ethically, and then there's should in the sense of like just is this in the interest of the business or something. Yeah, I think, defining the metrics that you're trying to move and asking yourself how much of a movement in that metric is this machine learning likely to do by doing some upgrade somewhere. And that's why I'd say start with rules or heuristics if you can, if you can get some like minimal viable, level of quality. So that's one thing, is using the metric to try and help you decide. Another thing is having baseline models or common models and maybe things that you're familiar with. So there's a lot of new models that come out of research and such. I remember at one NLP conference I was at, someone said like, "You machine learning people, you're our steroid providers. You keep on giving us all these new like muscle enhancers, and that's great, but we need to like really understand. We need to do the exercise, and we need to, I just want to do my push-ups or something like that." And the idea is to have maybe a few models that you really understand, even though they're not the absolute sexiest thing out there, and then be able to apply those quickly. So I'd say that's another thing to sort of have in your toolbox, is to say, okay, if it needs to be more than rules or heuristics, can I myself apply this model easily? And then if you work at a place that's big enough to maybe have some general models around, you can also use that. So for instance, with Discover Weekly, obviously that's very much focused on discovery. But let's say that instead of having a model focused on discovery, we just had a model that said, like, how much is this person likely to like this thing? And it wasn't at all discovery. We could just take that thing and then like throw out all the stuff that you listened to before and use it. So the idea is look around your organization for some model that's sort of proximate in problem space and try to apply that. Yeah, but it's a tough problem. And I think it's also kind of goes back to this values thing where I always say, we as developers are called to love our customers more than our code. Like let's get back to the ethics question too. Like, what is in their interest? And if you just want to like do the code for the code's sake, well, that's cool, I guess, but it's not ultimately in the interest of the business. So it's also having that ethos of like, get enough and go. Tough though.
I love your prompting questions. So keying in on the common features one, are there utilities? Is Spotify at the point where you're already creating a shared set of utilities to get machine learning questions kind of off the ground or quicker?
Yeah, I mean, definitely we have, internal teams that provide models to other teams and the output of those models and, tooling. So there's some open source stuff I can mention, like there's a data pipeline called SCIO, SCIO, and it has some things associated, like one's called Feetran that actually had its genesis in our office here in Boston that does feature transformations. So yeah, we've got this sort of toolbox. It's tough though. We really encourage teams to be autonomous. So it's sort of a marketplace, if you will. It's not that teams have to use this thing. It's more there are other teams that produce, these tools, and then their job is to make the tools, accessible and valuable enough that other teams are supposed to use them. Yep.
Who else we got? We haven't heard from this side of the room. There we go.
In one of your slides, you said that the team will compromise of applied machine learning engineer, machine learning tool engineer, and core researcher. I'm thinking about where is a person who validates whether the model is good or not, like for quality assurance or security purposes.
Yeah, so first of all, I don't think the team has to have all three of these roles. I'm more trying to articulate different roles and then saying, like in the universe, we all need these roles as a community, but it may be that, if you're using open source tools, you don't need a tool engineer in-house. But to your point about, where are these other roles? We were talking about analogies earlier. I think there's a whole rich analogy you could do with lumber, the production of wood furniture. And I like the quality person, maybe they're the person that's checking for splinters or something. So this is not meant to be comprehensive of everyone who touches a machine learning product, just those who are, let's say, writing code that ends up going into the building itself.
We got time for one more. Anyone? Okay, back there, making me get my steps in. Sorry, where was it?
Hey, David. Can you comment on the problem of coping with training data rot? So my company uses a lot of varied training data, and we've been struggling with a problem with one of our modules for quite some time, and only just recently did somebody think to go back and look at the training data. It turned out about 10% of it was completely bogus. And how could we have, caught this sooner?
Right. Thanks, Carl. So let's see. Where was I gonna put? Yeah, watch out for the drift in the data set. So yeah, there's a question of how do you measure the quality of the data itself? I think that you can do analysis just of the data. So what properties of the data do you have? What kinds of things are mentioned in it, or what are its sources, and try and look at summary statistics to say, did someone look at our training data for module X and count up the number of times that we see this or we see that or whatever, and it's sort of analogous to looking for duplicated data. So it's almost like validating on it. There's also one thing that people will do is test on their training data. So build a model and then look at your training data and look, is there some of it that really performs in an unreasonable way? So sometimes you look at an aggregate statistic, but to say, wow, on this training data, we really didn't do that well. So hopefully the 90% pulled the model, so it's going to be not as good on that 10%. And if you looked at what is our performance on this, are there some things that are really significant outliers, and then you could have sort of a inspection process. And then maybe just another is, and this is, I think, probably what happened, as errors come up and they're being classified and you're doing that error analysis, try to trace it back to, to what extent does our training data represent these sort of phenomena? But yeah, it's a tough problem. When in doubt, look at data, I suppose.
Awesome. Well, thank you so much.